Check points for lecture 1. Okay, to check your understanding on the material covered in lecture 1, it will be good that you try the questions and see whether you know how to do. Okay, let's start with checkpoint 1.1. Three objects A, B, and C are placed on a radius of a spinning disk, center O. Comment on the speeds of objects A, B, and C. Okay, so there are three objects and they are on the same spinning disk. So if they are on the same spinning disk, that means the omega angular velocity must be the same. That is, the angular displacement over the time taken to complete one revolution will be the same. So with that, we can use the formula V equals to R omega. With omega constant, velocity, the linear velocity will be proportional to radius. So A will have the smallest linear velocity because the radius is smaller. C will have the largest linear velocity because the radius is the biggest. Checkpoint 1.2. The minute hand of a clock is 3 meters long. What is its angular speed? So here you are asked to find omega. Okay, recall omega angular speed is 2 pi over t. The time taken for the minute hand to go one round will be 60 minutes. So you need to convert that to seconds. That will be 3,600 seconds. So the angular speed for the minute hand will be 2 pi over the period. You should end up with 1.7 times 10 to the power of minus 3 radian per second. Checkpoint 1.3. Refer to the question paper for figure 1.3a as well as figure 1.3b. Okay, so when the hour hand rotates from 12 noon towards 1 p.m., the minute hand will be inclined to the hour hand at an angle. The angle is 90 degrees on two occasions, as shown in figure 1.3a and figure 1.3b, which is in the question paper. Determine these times. Okay, so this is the diagram given that is for first part, when the minute hand and the hour hand is first at 90 degrees. The hour hand will have an angle displacement of theta 1 with respect to 12. So my theta 1, which is the angle covered by the hour hand, will be omega subscript h, because it's the angular velocity for the hour hand, times the time t1. Then the angular displacement of the minute hand will be theta 1 plus 90. So expressed in terms of radian. So for the minute hand, I have theta 1 plus pi over 2. And this will be equals to the angular velocity of minute hand times the time t1. Okay, so time t1 is what we want to find. So as you can see from here, we can find t1 by replacing theta 1. Okay, get rid of theta 1. So I'm going to sub theta 1 into equation 2, and then we find t1. So answer is 16 minutes. So the time taken from 12 noon, right, will be 12:16 minutes. Okay, let's take a look at the situation when the minute hand and the hour hand is next at 90 degrees. So the angle covered by the hour hand, this time round I call it theta 2. So we can form an equation for theta 2, which is omega h times the time t2. And the angular displacement for your minute hand will then be theta 2 plus 270. So that is 3 pi over 2. And this will be equals to omega t2. So same thing, sub-equation 1 into 2, and then we find T2. Okay, so from there we get 49 minutes. Oh, by the way, we need to work out omega for the minute hand. The minute hand will take 60 minutes to go one round, whereas for the hour hand it will take 12 times 60 minutes to go one round. Okay, I'm not converting to second. I'm leaving my answer in minutes, so the T2 will be in minutes. So the timings are 12:16 p.m. as well as 12:49 p.m.